Hey guys, welcome back to week 3 of your lesson videos. So I'm just going to go ahead and give you a brief rundown of what is going on for this week. So today we're going to be reviewing over 3.1 to 3.4. You have a ready to go on quiz, page 195, all numbers. That's going to be a practice for you. So one thing you're going to see a little different from this week is you'll see these orange classworks. Those are going to be the grades that'll be inputted for the week. Okay, so you'll see that really you have one grade going in this week. So this is your priority task. Everything else that's here is another review for you that you can go over. And if you have questions, you can always talk to me during the office hours. If you had an issue with a question or you didn't quite get something, definitely bring those questions up during the office hours. Another one that you'll see, I don't know if you can tell the difference between here, is this purple. Okay, so this is going to act as your interactive notebook or your journal entries. Okay, so I'm going to be keeping track from now until the end of fourth quarter, these discussion questions that are going to be posted in Google Classroom. So there's no right or wrong answer for them. I just want to see more of you being involved and talking with your classmates and having conversations back and forth. That's what I'm really looking for. So that's going to count towards your journal grade, which remember is a project grade at the end of the quarter. Same thing's going to happen. Okay, so there's going to be a certain amount of discussions that need to be completed by the end of fourth quarter for you to get that 100%. Okay, so on Monday, you'll see the video of 3.5 to 3.6, and this is going to be the classwork assignment that is due for PowerSchool. It's going to be the My HRW lesson 3.6. Next, we're going to be continuing to review Chapter 3. I'll also have this Chapter 3 pretest up for you on My HRW as additional practice. Wednesday, you'll be dealing with your Khan Academy, and again, that's your current unit that we're in, which Chapter 3 is related to functions, so that's what we're going to be going over. And then on Thursday, we'll have that discussion question for you to complete. I'm going to try to have all of this already uploaded by Monday so that if you want to start your discussion question on Tuesday or Monday, you will have that chance to do that so you don't have to worry about it later on. So what we're going to do now is we're going to go ahead and get started with 3.1. So this is where we're talking about the types of graphs that we deal with. Okay, so there's two types of graphs that we deal with, and they're called continuous and discrete graphs. So when I look at a continuous graph, that means that it kind of just has a line going through and it's a continual nonstop motion. Okay, so that means that it's counting all the points in between your X and your Y axis. When I'm talking about a discrete graph, that means that it's only talking about certain points and nothing really else in between. Okay, so every X has its own Y, same as here, but there's no line that actually puts them all together. So this would be something for every adult is $9. So this is gonna go 1, 2, 3, 4, 5, 6, and the Y is only gonna go by those amounts of 9 times 1, 9 times 2, all that, so forth, okay? So continuous, line that just continues, all the points in between. Discrete has specific points that it talks about, okay? So that is the essential point of 3.1. There's not really much more to go over with 3.1. So we are going to start looking now at 3.2. Okay, my computer loads. So 3.2 is going to deal with your relations and functions. And I don't know why it's not loading. All right, bear with me for a minute. Let me go ahead and reopen this. All right, there we go. So this is where we're talking about the 3 different representations that we have for showing functions. So we have our table, we have our graph, and we have what was called the mapping diagram. Okay, so I'm going to give you a brief picture of what each one looks like. So your table had your X and Y values, X, Y, and let's say 1, 5, 2, 3, 3, 2, 4, 1. So that was your table. It had your X and Y values represented. Your graph was just gonna be a random graph, had your little tick marks here, dot, 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 okay? That's how we could represent our graph. And then our last one was your mapping diagram, where you had your X values here and your Y values here. I'm gonna use the same ones from up top. So we had 1, 2, 3, and 4, 5, 3, 2, and 1. And this is where you would map every X value to its Y value, okay? So let's see who can remember how we could tell if something was a function or not. Anybody remember? And yeah. So if every X value was only linked to one unique Y value, so you see how in this case, every X value has its own Y, that's considered a function. But let's say that I changed this one here and I made it connected to the 1 as well. Every X value, oh, nope, I lied, not that way. Goodness gracious, get it together. All right, so that actually would still be a function. Doesn't matter if your Y has multiple X values, that's okay. But let's say that I had this 3 to the 2, but I also had this 3 to that 3. See how that X value is now connected to 2 different Y values? I can't have that, because I'm gonna end up having 2 points that are gonna intersect on that vertical line test that we talked about. So when we talk about domain and range, remember your domain values were your X values, range were your Y's. So if I wanted to identify what my domain and range would be out of, let's say, this little graph here. So I have 1, 2, 3, 4, 5, 2, 3, 4, 5. Let's say that I started a point here and I ended it, let's say, about here. So that's my graph. That's as far as it goes, right? So my domain values would be 1 to 3. So my X would be greater than or equal to 1, but less than or equal to 3, okay? It goes right in between there. Remember, that's called your compound inequalities, where they have an overlapping solution set. Now my range would look pretty much similar, but I'm looking at the numbers on this side. So I'm gonna put my Y in the middle. So Y has to be greater than or equal to 2, but less than or equal to 4. So this would be what my domain and range would consist of in this graph, okay? Now, let's say that this was an open circle instead of a closed circle. So that follows the same rules that we dealt with in your inequality graphs. So whenever we are graphing a linear inequality, that open circle meant it was not included. So it had that greater than or less than sign. So that means that I can look at the 3. So it has to be less than 3, but it can't be 3. And this one would have to be less than 4, but can't be 4. So you guys have to really pay attention to these, because they tell you which ones are going to be included, which ones are not included in your solution sets, okay? So again, we talked about how we can tell whether something is a function or not. And now that's going to bring us to 3.3. So remember, if you guys have any questions regarding any of this, please write down those questions, bring it to the office hours, and we'll talk about these, okay? So now we're going to look at writing functions, okay? So I am going to get a table. So I'm going to write out my table of values. I have my X's, my Y's, and I'm going to have about 4 pairs. 1 and -2, 2 and -1, 3 and 0, 4 and 1, okay? I need to write a function that's going to describe this whole situation going on in the table. So first I need to see, okay, what can I do to 1 to get -2? So I got to think about that. Let's see, I can subtract 2 to get -2. So I can do subtract 3 to get -2. So I can do 1 minus 3, or I can multiply it by -2 to get -2. Okay? So now I have to see which one of these is going to work for every single situation. So if I do 2 minus 3, does that give me -1? Yeah. 3 minus 3, does that give me 0? Yep. And 4 minus 3, does that give me 1? Last time I checked, yeah, it does. Okay? So that means that my actual function would look like this. Every x value is going to subtract 3 to get its y value. Okay? So remember, you're going to have to really pay attention about what's going on in these numbers and make sure that it works for every single case. Okay? Because it may have worked all the way up to here, and then what happens if it didn't work here? Then that wouldn't be the function that we're looking for, right? Now, we get to go back and talk about what our independent and dependent variables are. So our independent variables were our inputs, or our x values. So that's what was going into the function to get our answer. So that means that our dependent variables were our outputs, or our y values. That's what we're solving for in the end, basically. Okay? So let's talk about situations and how we can identify independent and dependent variables. So in the winter, more electricity is used when the temperature goes down, and less electricity is used when the temperature goes up. So which one depends on the other? Now, do I know how much electricity I'm using without knowing the temperature? No. So that means the amount of electricity that I'm using depends on the temperature that's going on in the day. So my independent variable would be the temperature, and my dependent variable would be the amount of energy that's being used. So you have to see which one, if I took away the other, would still work. So if I took away electricity from the temperature, it still works because my temperature is my temperature. Now, it doesn't depend on anything, it just happens, right? But if I took away the temperature from the electricity, I don't know how much is being used now. I can't tell whether I'm using more or I'm using less electricity during the day. So remember, the other thing that was talked about here is whenever we saw this sign. So this is what's called your function notation. This is that f of x, okay? So this can also mean your y value. And that's where a lot of you always got confused. You didn't know what to do when you saw this, but remember, it can always be substituted for y, okay? So if I had f of x equals x plus 2, that's the same thing as me saying y equals x plus 2, okay? These two are interchangeable. Function notation is just something that we would use if we wanted to plug in a value for x. So let's say that I said I wanted to do this one when it was f of 2. That means that I would take the 2 and replace it wherever I saw x, and that would give me my solution. All right, so the last one that we are going to talk about in today's lesson is 3.4, which is going to be talking about your graphing functions, okay? Now, this is where we can just solve it for slope-intercept form, okay? Remember, your slope-intercept form was your y equals mx plus b. And then we would make a table of values and then plot those points that we saw. Okay, so let's go ahead and choose an example to work on. So let's say that I have negative 2x plus y equals 3, and I want my domain to be -5, -3, 1, and 4. So that means that these are the x values that I'm going to go ahead and plug in and make my table out of. That's all that means, okay? So when I look at this, I can't really, I mean, I could plug numbers in, but again, I want to get it in that slope-intercept form. So I have to move this 2x to the other side. Now, I can't combine 3 plus 2x, which means they're just going to be right next to each other. Now, knowing my slope-intercept form, I know that this value comes before my y-intercept value. So I'm going to just go ahead and do that right now. Okay? So I'm going to make my table of values with the domain values that they've given me. So I have my x, y. So the domain values they want are -5, -3, 1, and 4. So that means I'm going to take every single x value here, plug it in, and get their y. So if I plug in -5 here, that gives me -10 plus 3 gives me -7. Same thing here, that gives me -6 plus 3 gives me -3. 2 plus 3 gives me 5. And then if I put in the last one, 8 plus 3 is going to give me 11. So these are going to be the only points that are represented on my graph. So I'm going to go ahead and make my graph here. 7, 8, 9, 10, 11, and then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now remember, these graphs are pretty much just rough graphs, okay? So we have -5, -7, which is about here. -3, -3. We have 1, 5. And then we have 4, 11, which is like all the way up here. So yeah, it's gonna be a little tough to see. So we can see here that yes, it is a linear function. Now this is all that they want represented in this table, okay? Because it only wants to see these domain values. That's why it gives it to us like that, okay? So remember that when we are doing these graphs, you are more than welcome, if you can't remember how to do this, which we haven't gotten there because that's chapter 4. So we're gonna take these functions that they give us, plug in x values. Now remember, if they don't give you x values, remember the points that I always told you to choose. -1, 0, 1, and 2 are gonna be your best bets, okay? So just remember that. And if you guys have any questions, please bring them to the office hours, okay? I need you guys to bring specific questions to work on together so that we're not wasting time trying to find a question, okay? You're more than welcome to email them to me so I can maybe have them worked out on a sheet of paper so it doesn't take so long for that as well. Or upload them to the Google Stream, okay? Again, my office hours for you guys, please remember those office hours. So period 2 is from 9:20 to 9:35. Period 3 is from 9:40 to 9:55. Period 5, 12:20 to 12:35. Period 6, 12:40 to 12:55. Please remember your office hour timeframes. If you cannot meet during those times, set up an appointment with me and we'll talk either from 8 to 8:30 in the morning or on Monday, Wednesdays, and Fridays, 6 to 6:45 at night. But remember, those are by appointment only. I'm not on the Zoom meetings unless someone has requested that time with me, okay? So I look forward to talking to you guys on Monday, and we will go through 3.5 and 3.6 then, okay? Bye.